Let's consider example number 4, and this is example 4 for lab number 2. In this case, we're provided with two planes. One is specified as having a strike of 166 and a dip of 32 degrees. Given that this follows the right arm rule, 166, that requires that the plane dips to the west or perhaps the southwest. Plane 2 is described as 038, 58. Given that that strike is off to the northeast, right arm rule dictates that that must dip to the southeast. In this case, we're asked to determine the line of intersection, the intersection between those two planes, and the angle between the two planes. The line of intersection, that is in fact a line. So that'll be described in terms of plunge and trend. We've not really talked about plunge and trend a lot yet. We will, but let it suffice for now that we are going to need a plunge angle, the angle at which it plunges into the ground, if you will, and a trend, and that'll be the compass direction of that plunging direction. All right. We could have done this by orthographic projection. It's rather tedious, rather complicated by orthographic projection. It's much easier to do this kind of problem in spherical projection with a Stereonet. So that's what we'll do. All right, so let's start by just placing our overlay. Oh, by the way, of course, I have the Stereonet. Let's place the overlay on the Stereonet. Push the tack up through the overlay so the overlay spins freely on that Stereonet. First thing we need to do now is to mark north. There's north. And then we need to trace the primitive great circle. I'll remind you that I'm using a pen and regular paper on a light table. I would suggest instead that you use tracing paper. It's much easier to see. And that you use a pencil and that you have a good eraser handy to erase your mistakes. Okay, there we are. We're ready to go. So, plane 1 has a strike of 166. That is right there. Mark that. 166. Plane 2 has a strike of 038. Right there. 038. Again, 3 digits with a leading 0 to confirm that that is in fact an azimuth. And azimuth compass directions are indicated around the outside of the primitive great circle on the Stereonet. Let's remind ourselves of this right arm rule thing. If I place my little Lego lady here, such that she faces the compass direction 166, her right arm in that case points off to the west or southwest. That means, of course, that my primitive great circle is going to lie over here to represent that plane. To put that great circle in place, I need to rotate the overlay such that 166 is on the north-south axis. And then in this case, I'll count in 32 degrees from the west edge of the Stereonet along the east-west axis. 10, 20, 32 degrees brings me to that point right there. And I will trace that primitive great circle. Now, before I move the Stereonet, I am going to put the pole to that plane in position, mark it, and I'm going to do that because I happen to know that in this case, the poles to these planes are going to serve good purpose. In fact, we're going to measure the angle between the planes as the angle between their poles. So, The easiest way to put the pole to this plane on the Stereonet is to leave it in this position, and just as we counted, let me go ahead and label this. I'll label this 32 degrees. That's the dip. And just as we counted 32 degrees in from the outside to that great circle, we can simply count 32 degrees out from the center to position the pole to that plane. I'll go ahead and label that too. That is 32 degrees, and that is the pole. Let's go through the same exercise for the other plane, plane 2. Again, if I face 038, my right arm is over to the southeast. Therefore, the great circle belongs over here. So, to do that, I'll place 038 on the north pole of the net, and I'll count in its dip of 58 degrees in from the east edge of the Stereonet. 10, 20, 30, 40, 58 degrees. Brings me to right there. And I can trace that great circle. Okay, and in this case, well, let me label that. That was 58 degrees. All this labeling isn't generally necessary. I'm doing it now just to make this, make it clearer what it is I'm doing. With the Stereonet still in this position, with 038 on the north axis of the Stereonet, or the north pole, let me count the 58 degrees out from the center in the opposite direction here to place the pole to plane 2. 10, 20, 30, 40, 58 degrees puts its pole right there. And that is that 58 degree angle. Okay. So the two planes and the two poles are on my overlay. And here's what they look like with the overlay in its registered position, with north on the north pole of the Stereonet. My interest, the line of intersection is given right here, where the two great circles intersect. To get the specifics for that line of intersection, both the plunge angle and ultimately the azimuth of the trend, I should move that up to an east-west axis. It really didn't matter. I could have put it on the east axis, or I could have put it on the west axis. I'm right-handed. I find it easier to use the east end of the Stereonet. I want to place that intersection precisely on the east-west axis and put a tick mark on the primitive great circle, and that is going to be the trend of the line of intersection. But I can't determine the trend yet, because I'll have to reposition the overlay in its registered position to do that. While it's in this position, however, I can count the plunge, and that is 10, 20, 22 degrees. While the overlay is in this position, we'll notice something else. That is, while the line of intersection is on the east-west axis, what has also occurred is that the two poles lie on the same great circle right here. And the angle between the two planes is then given by the angle between those two poles. So that's this angle right here. And let's go ahead and count that angle. I'm in the habit, when I'm doing this kind of thing, I tend to count the 10 degree divisions first, and then sort of account for the extras. I've got, that's 10, 20, 30, 40, 50, 60, 70. I've got an extra 5 degrees there, 75, and conveniently an extra 5 degrees here, so that is an 80 degree angle. 80 degrees. And that is, in fact, the angle between these two planes. The plunge is 22 degrees. The angle between the two planes is 80 degrees. And the trend is, that's 180, 190, 200, 204. Tell you what, let's go ahead. This is the pole to plane 2. This is, in fact, plane 2 and its pole. This is plane 1 with a strike of 166 and a dip of 32. And this is the pole to plane 1. This is the angle between the two planes. This is the line of intersection. The line of intersection plunges 22 degrees in the direction 204. All right? Let's go ahead. I'm going to go ahead and see if I can do that. So, let's say plane 1 intersection plane 2 equals 22 degrees, 204 degrees. That's the plunge and the trend. Plunge and trend of the line of intersection. The angle between the two planes, the acute angle between the two planes, equals 80 degrees. That's it.